equal, but with different signs. To be -1. All right. So if they have to be equal with different signs, we just have to find out which quadrant has them being negative, and see go from there. So we know that, let's say, remember x is equal to cosine of theta. That's negative in quadrant, remember, x is negative in quadrants 2 and 3. Make sure I put my x and my y there. Quadrant 3. And y equals cosine of, well, sine of theta. And the only reason I changed this to theta is just because we're now dealing with x's and y, so I didn't want to have sine of x is equal to x and all, so I just changed it to theta. It doesn't change the value of it at all. Sine of theta is negative. I don't know why I put in. It's negative. Okay, so y is negative in 3 and 4. Quadrant 4. Okay, so we can't have both of them being negative, so we know quadrant 3 is out. Because if we had a negative divided by a negative, it would give us a +1. Okay, so we can have either quadrant 2 or quadrant 4. Okay, so in quadrant 2, now this is where you'd have to go to your chart and find your actual values. So in quadrant 2, tangent of 3 pi over 4 equals sine of 3 pi over 4 over cosine of 3 pi over 4. Okay. Now in quadrant 2, this is equal to negative square root of 2 over 2. And cosine, your x value, is equal to positive square root of 2 over 2. Okay. So these two, anything divided by itself would just be 1. And you have a negative there, so that's going to equal -1. Does that make sense? All right. So now we do the same thing, but in quadrant 4. Now in quadrant 4, you now have tangent of 7 pi over 4. That will have them both equal, but with different signs. Which is going to equal sine of 7 pi over 4 divided by cosine of 7 pi over 4. But in this case, the sine is positive, square root of 2 over 2, and the cosine is negative, square root of 2 over 2. Again, anything divided by itself is just going to equal 1. So again, you get -1. Okay. So we know just from there that x equals pi over 4 will make tangent of x, pi over 4 and 7 pi over 4. Forgot to add that one. So pi over 4 and x equals 7 pi over 4 will make tangent of x equal -1. Nope, 3 pi, thank you. Nope, it should be Yep, 3 pi over 4. Yep, that's right. Stop. We're not talking about tangent. Quadrant 1. Quadrant 1 is pi over 4. Then quadrant 2 is 3 pi over 4. All right. So any questions on this one? All right. Okay, so now we're going to talk about shifting the graphs, which is really kind of going back to how we just shifted regular functions. Because the same rules apply, so it's kind of a review. All right, so let's say, not for example, I think I'll review it first before we go to the example. So if you remember, should be from pre-calc, we did our shifting of graphs, that if you have some f of x plus c, that means f of x is shifted c units up. If you have some function of x minus c, that means that function is shifted c units down. And if you also remember, negative f of x is just f of x, but you'll flip it. Clean that up just a hair. Okay, so let's say, for example, if you wanted to graph, or in this case sketch, I can't really say graph because we're not putting in actual points, we're just kind of looking for the general idea. So sketch f of x equals 3 plus sine of x. Or you can make it sine of x plus 3. Now I'll make that or f of x equals sine of x plus 3. All right, so let's say if we start with our sine of x. And we'll make that, instead of f of x, since we're already using that, we'll make that our g of x. Okay, so this is our sine. Kind of go like that. Okay, so we know that's our sine of x. Move that down a little bit. Okay, so this is our sine of x. So sine of x plus 3 is just sine of x shifted up 3 units. Okay, so remember this starts at 0. It goes from 1 to negative 1. So if we rewrote that, actually I can go ahead and fill that in, because we're going to just draw another graph to avoid it looking too jumbled up. Okay, so that's your sine of x. So that means if you have, just redrawing your sine of x here, and this time I'll just lightly draw it in. Okay, so this is your sine of x. Remember, from 1 to -1. Make this a little bit taller. Take that up just a smidgen more. Okay, so that means this entire graph is just going to shift up 3 units. So this is 2, this is 3. So instead of starting at 0, it's going to start at 3. And instead of this going up to 1, this is going to go up to 4. Instead of this coming back down to 0, it's going to come back down to 3. Instead of going down to -1, this is going to go down to 2. And it's going, instead of going back up to 0, this is going to go up to 3. So that very same graph just looks, oh, that was horrible. So hopefully you get the idea. Where the entire graph, every point on that graph just shifts up 3. So, all right, let me try and redraw it a little bit closer to the actual sketch. Close enough. All right, so this f of x equals sine of x plus 3, which is just sine of x shifted up 3 units. All right, so in your homework, what they'll do is they'll ask you where sine of x, f of x equals sine of x plus 3, and they'll give you like 4 or 5 options and tell you to pick the right one. Okay, so really in this case, you just look for the option where the graph is the same, it's just shifted up 3. All right, any questions on that one? All right, and if it was -3, then that entire graph would just shift down 3 units. All right, so let's say, for example, if we wanted to do a quick sketch of f of x equals negative sine of x. Okay, so remember that negative f of x is just f of x flipped. Okay, that's all that negative sign means. You're just going to flip the graph over. Okay, so if we did a quick sketch of sine of x, and actually we can probably do both of them on the same one. So this is our x, and that's our y. If we kind of lightly dotted our f of x, our sine of x, that means this one's going to flip over the x-axis. So that means this now becomes, make that a little bit bigger. Okay, so that becomes like that. All we did was flip it. And this flips and becomes positive, so that now becomes that. So this is our negative sine of x. Because if you think of it this way, for sine of x, these values are all positive. But once we multiply them all by -1, those same positive values now became negative y values. And these negative y values, as soon as you multiply by -1, they all became positive y values. That's why it's just flipped over the x-axis. Right? Does that make sense? All right. All right. Any questions on that one? Okay. So now let's scroll down memory lane to our stretching vertically and horizontally, or stretching and shrinking rather. So if you remember, and let's say we'll let A represent some real number. Okay, so let's say that y equals, uh-oh, forgot my A. Say A of f of x. So you're just multiplying some function times a number. So it stretches vertically if A is greater than 1. Okay. So if you have 3 times x, then every value of x just gets multiplied by 3. So it stretches vertically. Every value gets a little taller. Okay. Y equals A times f of x stretches, or not stretches, shrinks vertically. Uh-oh, pencil lay it there. There we go. Shrinks vertically if A is a fraction. I guess I'll put the A as a fraction. And A is between 0 and 1. Well, I guess you can say no equal to there. Okay, so if you have x equals, let's say, f of x equals x. If you get that f of x equal x, if you plug in a equals 1/3, then every value is now divided by 3. So instead of going up, each value drops down. So it shrinks vertically. Okay. So also, since these are a little bit different, I'll start a new line here. F of x, let's say x minus b, means that f of x shifts to the right b units. And this was the one that was a little bit tricky because when it's minus, it shifts to the right, but when it's plus, it shifts to the left. So f of x plus b is that f of x shifts to the left b units. Put little quotation marks there. Okay. So the very same thing is true for trig functions. Let's say if you let y equals a times sine, and instead of x, I'll use k. Well, I'll use x. Actually, I need the k there. Sine of k of x minus b. And we'll also, since they're pretty much the same, y equals a cosine of k times x minus b. And we'll assume that k is positive. Now your a is equal to your amplitude. which is really just saying just how high up or how tall your graph is going to get. So when that a is equal to 1, sine goes between 1 and -1. If that a was equal to 2, sine would go between 2 and -2. And it just keeps going like that. Because every value between there is now multiplied by 2. Okay. That's the largest value of y. Nope. Actually, you might as well put the absolute value there. Okay. Now 2 pi over k, that's the period. That means just how far or how much space it takes to go from 0 up to 1 and then down to 0, then -1 and back up to 0. That one complete cycle, that's how many you'd have in there. So 2 pi over k is your period. Okay, so this is just a complete cycle. Okay. So like I said, if we wanted to do a quick graph of it, this would be your cycle, or one cycle, at least for sine. Okay, now an interval of a complete period is actually b plus 2 pi over k. That means if we shifted this to the right or to the left b number of spaces, then the entire period would still be the same thing, but it would just measure how long the period is. But it's just shifted either to the left or to the right. Okay, where in b is actually just where it shifts. So they actually call that the phase shift, which is how many units left or right it shifts. Uh-oh, forgot my T. How many units left or right the graph shifts. All right, let me kind of separate those. All right, so let's say, for example, let's say you want to find the period, amplitude, and phase shift of f of x equals 3 times sine of x minus pi. Okay, so the first thing you want to do is you want to compare it to your general formula. So absolute value of a, sine of k, times x minus b. You can kind of line that up right with it. So you have your 3. If you want, you can put absolute value of 3. You don't have to. So you have 3 sine. Now there's no k here, so you can actually put 1 if you wanted to. You don't have to. But if you want to just line it up, make that x minus pi. Okay. So our amplitude, remember that's absolute value of a, which if you line those right on up, is absolute value of 3, which is 3. Now our period, which is equal to 2 pi divided by k, remember our k is equal to 1. When there's nothing there, just like if you're multiplying a number, you automatically assume it's a 1 there, which is 2 pi over 1, which is 2 pi. Okay, now your phase shift, remember that's equal to b. So in this case, your phase shift is pi, which means it's positive, so it's shifted to the right. Shift pi units right. Because remember, when it's minus inside of there, it's shifting to the right. Okay. Now they didn't ask for the interval, but I'm going to just show you how to find the interval. Okay, so remember your interval is b plus 2 pi over k. Okay, which means that your interval, your b, is equal to pi. So it's pi plus 2 pi over 1, which is just 2 pi, but I'll put it there anyway. So you have 2 pi plus pi. So your interval is actually between pi and 3 pi. Okay. So if you were graphing this, it would start at pi, then go through the regular sine wave pattern, and then would end right back up at 0 at 3 pi. Okay, so it would look somewhat like this. Okay, so our regular, I'll say that's our regular sine wave here, from 0 to 2 pi, so that's your 2 pi here. Move that over. I don't know why I started in the middle of the page. Okay, so let's say this is 3 pi here. So this is our pi over 2, and our 3 pi over 2 here. And this would be our 5 pi over 2. Okay, so if this shifted, that means instead of starting at 0, it would now start at pi. So everything here now shifts. So instead of going back to 0 at pi, it's starting there, which means it would go to 2 pi. Because this goes from 0 to pi. So now it goes from pi to 2 pi. And instead of going between pi and 2 pi, it would go between, oh, did I misdraw? I should have made that 3 pi a little bit closer. It's not necessarily drawn to scale. Okay, so 5 pi over 2, 3 pi. So this is shifted also. That was way off. But hopefully you get the idea. Where the entire graph is just shifted. Oh, I cannot stand the way that looks. I swear, if I could go through a whole math class without drawing, I'd be happy. Okay, so this is 3 pi. Okay, so we just got that whole graph. Oh, actually, I should have made it taller because the amplitude. I was so busy focusing on my horrible drawing. Because our amplitude is 3, this actually goes